Yeah. Thank y'all so much for coming. I know that it's been a really long day for everybody, so I really appreciate you sticking around, listening to the great presentations. My name is Chow, and over the next 90 minutes, we will build an agent together. So I hope you have your laptops up and ready, and if not, I hope you have a great partner. But it's going to be super simple. There's no prerequisites except for a GitHub account, but we can talk a little about it later. But yeah, about 3 weeks ago, actually, I was listening to this really great podcast about agents. And I just, it really stuck to what I work on. And it really relates to this workshop. So I wanted to share a little bit about it. So we're going to be working in parallel here. And the whole gist of the whole podcast and the episode was that an agent is only as good as its data layer. And for me personally, I'm going to just talk a little bit about the presentation. But I feel like so many people focus on the top part of the application. But if you really, I just really want to bring focus to just how the data and how an agent runs is really, it's really important. And you can really change the way that your agentic system works by really changing the way that your data is stored. So hopefully we can both build an agent and learn a little bit about them too. But first, a little bit about myself. I am a product manager at Microsoft. I work at databases, specifically NoSQL databases and MongoDB compatible databases. I work in Azure Document DB, if you're ever interested. But I am also a maintainer, an open source maintainer. I run the Document DB project, the project. It's an open source MongoDB compatible database, and we'll be actually running our product on it. I built this lab, and so I'm here if you have any questions. And that's my cat. Her name's Arepa. And I think she's still trying to formulate a thought, but it's okay. She's getting there, yeah. Yeah, but so before I get started on my presentation, I really want to encourage you to open your code, open your GitHub code spaces. The lab itself takes a while to get set up. So, and I'm like the type of person who likes to kind of work on something while listening to a presentation. So if that's you too, then you can do that. If you want to listen to this presentation and then get started on the workshop, I'll be walking around to answer any questions. But the first thing that you want to do is go to github.com/documentdb/booking/agents-sample. And you just click on the big button on the README itself. It's just opening up code spaces, and for this workshop, you'll also need an OpenAI API key. If you have an OpenAI account, cool. You can use your own API key. If you don't, you can use mine. If you go to aka.ms/howdyAPI, you can get the API key yourself. But we can get started. If you have any questions about what's going on, just raise your hand, and I'll be answering questions throughout about just getting the code space set up during my presentation. Cool. So what is in the code space? Yeah, what are we going to build? So the app itself is a booking assistant for Airbnb-style listings. So you ask for a place. Right now, I used public data from the Denver area. And so you're going to ask it questions, and it's going to match what you asked for. So the UI is a React front end. The back end is Fast API. And the data layer is DocumentDB. And we're going to run it on a Docker container, all within your code space. So there's going to be 3 modules. The first module is vector search. And the second module is, what is it? Oof. So we'll take during vector search, we'll take a data set of Airbnb listings, generate embeddings for the descriptions, stick it in DocumentDB, and just start searching. The second module is RAG, which stands for Retrieval Augmented Generation. We'll glue that to an LLM, handle chat history, and start getting real conversational answers. And the last module is really building a multi-agent system. We'll use LangGraph to split the work with specialized agents. And if you just listen to that and you're like, Patty, what is going on? That's what I'm here for. And I will be breaking down each part of the module here. So before we get started, if you are going through the presentation and you really like what we're doing, here are some 3 QR codes. So the first one is our website, and I'll be posting these later. But this is our website. You can find everything, just every bit of information here, blogs, everything. If you want to look at the code base itself, we're open source, MIT licensed. Please scan the QR code on the right. And feel free to leave a star if you are so generous. And lastly, if you are building and just happen to run into any questions here, or I guess maybe here you have me, but afterwards we have a Discord here available. So would really appreciate the support. But as I said in the title, the whole workshop kind of lies in one line, in my opinion. Your agent really is as good as the data layer behind it. And I feel like whenever I'm scrolling on YouTube Shorts or TikTok or Twitter, I just see everybody choosing between different models and frameworks with what's better, Claude or GPT, LangChain or LangGraph. And these choices really do matter. But for me, I think there is a big quality gap that people aren't really talking about. It's, you can have the same module, the same prompts, but if you really swap the data layer underneath, you can have a completely different product or project. If your data layer can't do vector search, then your agent can't find what users mean. If it can't hold state, your agent forgets what it said 2 messages ago. If it can't filter, you get just this really detailed answer. That was probably someone joining on Discord. Thank you, guys. But if you can't have filter, then maybe you have hallucinations. And honestly, this is where, in those moments, I just kind of get mad at my agent. And I'm like, what's going on? So, But a quick, before we get right into the present day, I would love to step back and look at the shapes of LLM applications. So in the first stage, I remember back in 2022, everybody was just starting new chats on ChatGPT, and it was just chatbots. And it was just an LLM by itself. You type, it replies, and it was helpful for a lot of things, but it only knows what it was trained on. Ask it about things in your company, and it makes things up. Ask it for yesterday's news, or maybe even current events, and it doesn't know what's going on. In the second stage, 2023, you had retrieval. We solved the, it doesn't know your data problem by doing a lookup before generating. You go to a knowledge base, and it pulls out the relevant documents, stuffs it in the prompt, and the model is grounded. That is RAG. And that is what most AI products that are out there today are doing. And lastly, it's agents. Retrieval is still a one-shot, and agents loop, and we're going to talk a little bit more about that. And the reason about what they do, they take action. They see what happened, and then they try again, and they keep learning on top of themselves. And that's really where we're going. Each stage has depended on the one before it, and you can't build a good agent without a good RAG, and you can't build a good RAG without a good retrieval layer. And a good retrieval layer, it is, again, a data layer problem. But before we build anything, and while your code space is probably still getting built, I really want to be precise about what an LLM is. An LLM is pure function. Prompts in, tokens out, that's it. And you essentially get pretty much the same answer every time. It has no memory of your last message. It has no idea what it is. It can't reach out and fetch anything for you. It's just prompt tokens. And everything that your agent does just kind of feels like, yeah, everything that your agent does that feels like memory, or it knows what it's doing, or it found this thing from a chat in the past, none of that is the model. That's just the model is just the generator. What takes in prompts and puts out answers. And the data layer is the things around the model that provide context. It remembers history, it retrieves facts, and it stores state. That really matters because whenever something goes wrong with your agent, the first instinct is to blame the model. ChatGPT or my Claude chat, it doesn't really know what it's doing. Or I guess my self-made chatbot, in this case, doesn't know what it's doing. It hallucinated. And it usually just isn't the model. It could be what you did or didn't put in the prompt, but sometimes it is a data layer problem. And if you understand the data layer itself, it could be something that you can fix. I think I kind of covered a little bit about this, but I guess some things to understand when it comes to the problems. Maybe, there could be 3 gaps that comes when it comes to not knowing about your data layer. So first, maybe if you're working on something for yourself and you're trying to train it on, how can the chatbot pull out what you know without kind of telling it what you know and organizing it in a way that is digestible for the model or the agent itself. So the gap number 1 is that it needs to know your data. And second call is that sometimes when it comes to lacking a data, when you prompt a model and it has no data layer, it has no memory. So each call is just completely stateless. The conversation feels like the model remembers what you said earlier. That's something that's good with your data layer. And third, if you're just putting in a prompt and it doesn't know anything about you, it doesn't know what to do, and it essentially can't do anything. When it comes to fixing those issues in your data layer, I really want to kind of get down with the basics. And the first step that we have to learn, and something that is in the first module, is embeddings. So the way that I like to explain embeddings, it kind of feels like a fingerprint that provides meaning for words. So there are texts or I guess ideas go in. So downtown condo, for example. A model takes in a downtown condo, and for you, it could look like that, like a series of letters. But for a model, it looks like a list of numbers, also known as a vector. So these 2 phrases, for example, downtown condo and city house, they're 2 different words, but their meanings land close together, which means that their fingerprints themselves are kind of similar to the above. On the other side, mountain cabin is very different from city house or downtown condo, which means that their fingerprint for meaning is completely different. It's the difference, numbers themselves are just very separated. Therefore, it has a different vector. It has a different meaning. Once your text is a vector, similar, as you can see, it just becomes a math problem. The cosine similarity between 2 vectors gets calculated. If you want to see the similarity between one and another, you have to do a cosine similarity search. And it just provides, you just get back a number between 0 and 1. That's how similarity search works. Yeah, so this is what vector search actually looks like in the demo itself. So we have pre-computed embeddings for you in the modules, and store them. And then what you do is you're going to store them in the data layer, document DB. And to query, you're going to do 3 things. So first, you take a query, or I guess the the model itself takes your query, so cozy apartment with parking near downtown or something like that, and it looks at the embedding itself. Second, we run an aggregation pipeline with the listings collection, and we use our own, a search model called Cosmos Search. You'll learn a little bit about it. And the Cosmos Search says, find me the top 5 nearest neighbors, get me the things with the 5 listings with the search that's closest to 1, the highest search closest to 1, and it pulls it out. And then in the third stage, you just project the listings themselves. So if we're looking for something for a cozy apartment with parking near downtown, you might get downtown studio with parking, which has a similarity search of 85. City center apartment. 2, I guess, even though it only shares 1 word, the city center, downtown, they have this matching, they kind of have similar fingerprints. So it's going to be ranked higher. Now, I went to UT. UT's a little bit farther from downtown. So if, and it's not really, UT Austin, a studio could be an apartment. It's pretty similar, but UT Austin is very different from staying downtown. So the similarity search does decrease. So vector search alone gets you a list of listings. RAG is what really turns, search and retrieve into a conversation. RAG, again, stands for Retrieval Augmented Generation. So, and it comprises of 3 stages: retrieve, augments, and generates. Retrieve is kind of what module 1 is, and then the augmented stage takes those results and stuffs them into the prompt as context. Generate then means that the LLM produces a grounded message, thus using that context. So you as a user, you send a message. If it's a follow-up, the model rephrases it into a standalone question using chat history. So more on that later. Then we embedded the question, run Cosmos Search, top 5 listings come back. We format them as readable text and inject them as context. The LLM then reads the context, reads your question, and writes a conversational answer using the listings above. So why are we using RAG? By implementing RAG into our data layer, it ensures that our response just is grounded. The model isn't guessing what listing exists. It's pulling real listings from our real data. If the context says that the loft is $125, it doesn't pull from a random price up in the air. It doesn't create one. So there's no hallucination and no stale data, and we can just swap in and out new data as we want. So here's the thing that RAG gets out of the box. It treats every question as the first question. So that's fine for a one-shot search, but conversations aren't really one-shot. So here's an example. If I put in the chat, find me a cozy place in Austin for the weekend, in the search we find 2 great options. Like the model recommends them, and then you can type, hey, well, I don't know, like, does the first one have any parking? Totally normal human follow-up that you can totally ask in the chat. But without RAG, what is it? There's nothing useful for it. There's no, it just doesn't, it forgets the conversation itself. And when it comes to building RAG, we're actually going to build the history behind it. Yeah. So moving on, we have vector search implemented in our module. We have RAG. But what actually, moving forward, if we're building an agent, what makes it an agent rather than just something with RAG? So an agent takes memory, it takes context, and it continues looping. So there's 3, it keeps looping and it keeps learning from it. Sorry, it's a lot of talking. But there are 3 phases to this. So first, there's reason. So it looks at what the agent now looks at what the user wants. It looks at the current states. It just decides what to do next. Then it acts. It takes action, usually by calling a tool, and then it observes. It sees what happens, and then it goes back to reason. The loop runs until the agent decides when the task is done. So whereas RAG is basically just one pass through this loop, and with a single tool, vector search, an agent can have many tools. And you've probably seen how agents can pull from different tools or connectors in your day-to-day life, or as you are kind of learning more about agents personally. Some of the tools that I've seen it used is like search. It can access the internet. It can check my email, and based on I was able to make a reservation the other day, and based on my prompts or queries, agents can pick the best tools that can help itself reason, act, and observe, and continue the loop. The reason this matters is that the loop's shared state. So what's been decided, what's been retrieved, what the user said, it has to live somewhere. And that somewhere is the data layer. So the state between reason, act, and observe is a data layer problem. If you can really, I guess if you conceptualize this in that way. A little bit about the demo itself. We'll be actually having 5 agents. So one of them is going to be a generalized agent, whereas we're going to have 4 specialists. So as you keep building, what is it? So if I have, so as I'm building and I kind of have to pull up the chat again, I can type in, hey, if I have like a basic query that applies to the Airbnb data, if I say hey, I'm looking for a weekend getaway in Denver, I'm looking for a cozy apartment downtown. The supervisor app then recognizes it as, I guess, Airbnb related question. And it takes it to a search agent. The search agent is specialized to, search through the data. The filter agent filters the data through any filters that you put in on your query. So if you want to say that you need parking in your apartment, in your cozy apartment downtown, then it does that. You can, if you prompt that you want something that is that has at least 3 bedrooms and 2 bathrooms, it can filter on that. Then it's the recommendations. It grabs your past chat history and it recommends it by what you think you might like. And lastly, we have an agent that just responds in a very conversational manner. Now, couldn't one agent just do all of those things? Yes, but having a multi-agent system allows each agent to be specialized in what they like, just in a thing. So each thing can do what it does best, and it provides any failures. I'd rather have a lot of specialized agents than just one sloppy one. And if I just type something like, hello, or I am looking for a horse, not a house, then the agent itself can say, hey, maybe this is not the right platform for you if you're looking for horses and not houses. Yeah. But I know that I talked about a lot of things. We talked about embeddings, RAG, multi-agent platforms, yeah. But here's the thing. Learning about all of this is just the tip of the iceberg. What actually decides whether your agent works in production, whether it's accurate, whether it's fast, whether it's maintainable 6 months from now, comes with building a data layer that is the right for you. The patterns that we just walked through aren't what's hard. It really is about building the thing that is right for you. But in general, when you pull the data layer apart, agents, they need 4 distinct jobs from it. So one is vector similarity. That's embeddings, nearest neighbors, close distance. that's what we're going to learn in Module 1 as we're working through the workshop. 2, it's document lookup. Once a vector hands you its IDs, you need the full listing name. So name, description, price, amenities, coordinates. That's a plain key value that you fetch against the document store. Every RAN calls ends with this. Third, I guess we talked about a little bit about filters. And lastly, state. You need, so every data layer, like a good data layer needs its own piece of history. But how do you find, so when it comes to databases today, especially ones that serve, that kind of build for AI, sometimes you just have to build a Frankenstein architecture. And that's the problem that we faced at Microsoft. So, you know, especially when it comes to open source, how do you find a platform that does everything that you need to do? Sometimes you just have to stitch. So maybe a big framework for vectors is Pinecone today. You know, you can go to NoSQL, any NoSQL database for your documents. Or any other database, but does it store vectors too? Who knows? Sometimes you have to use Postgres because you need filters, and sometimes you need Redis because you need some stored history or states. But now you have you're using 4 different tools, which means 4 different connection models, and you have to find 4 different ways to do what you need to do. And I'm not saying, like, and maybe it works for you. Maybe it works for you. And I'm not saying that stack never, that the stack that you build will not make sense. Maybe it does. But for most agent apps, there's just going to be, you know, if you want to really face a problem, you need to understand it first. And sometimes if you don't understand it, you can get into a complex standpoint. At Microsoft, we really wanted to build something that kind of did all of that. It stored your vector, your documents, your memory, and you could still kind of use it in a relational background. And so, and that's where DocumentDB kind of comes in. It uses an MIT license, so you can use it for free forever. We recently actually donated to the Linux Foundation, and it's been great ever since. So you can just run it everywhere, fork it if you want to, and yeah. Secondly, it's you know, if you are actually by a raise of hands, like who builds on Postgres or who builds applications using Postgres? Oh wow, a really good amount, like good chunk. And who here uses NoSQL or MongoDB? Okay. Awesome. Well, if you are coding with MongoDB, it is completely MongoDB compatible. So you can just use the connection string like you would on MongoDB Atlas or Compass. And great thing for all you Postgres developers, it is completely based on Postgres as well. So you can actually run your Postgres queries against DocumentDB, which is really cool. And lastly, you can store your vector embeddings on it. So what is it? Yeah, so you have full text search, geospatial, all running and storing in one simple engine. But by the time I talked, I hope that your dev containers have built in GitHub Codespaces. If you need any more help, we're gonna get started. So who here has GitHub Codespaces already built in the platform? Okay, awesome. Does anybody need any help getting started? Does anybody need to see the information again on how to do that? Okay, great. Let's spend a couple of minutes opening up the Codespace. So the first thing that you're going to do is go to github.com /documentdb /booking-agents-sample. Yeah, thank you. Yeah, and in the README, the first thing that you should see is a big button that says Open in Code Spaces. You click that, wait a couple minutes, and the container should be building. One thing that I also mentioned is that you need an OpenAI API key, but I actually created one for you. So if you go to aka.ms/howdy-API, I mean, feel free to use your own. It's just the OpenAI API key. But for those who use another platform or are starting to get into AI, you just copy and paste it. This will be useful later. Yeah. Oh, awesome. Thank you. My gosh. Wow. Thanks. OK. Cool. I guess the time is, it's around 5. So for the next hour, feel free to, I'll be here if you have any, we can have a couple minutes for questions. But I can also just walk around and help everybody get set up. Cool. Well, I guess that's it for me. Thank you so much, everybody. But if you're already in the... Hi, everyone. We're just closing out the workshop. But yeah, just to answer one big question, if you want to get started after setting up your code space, what you do is you click the button here, you start here, or you go to exercises, and then module 00. And then you get started. The cool thing about this is it's all set up on code spaces. So whenever you get home after this event and after all the lightning talks, you can just, or even right now, like you can just get started. I'll keep the API key open until tomorrow morning. So you can just go to aka.ms/howdyAPI. And oh my gosh, there's so many people here. So just feel free to copy and paste it. And that's on me. So yeah, if you have any more questions, feel free to reach out to me on Discord. Thank you, everybody, so much. Yeah. Right.